Example on buck regulator. In the previous two videos, we have presented detailed study of a buck regulator. Now we are going to present a numerical example about the buck regulator. The buck regulator in the figure, this buck regulator has an input voltage Vs equals 12 volts. So the source voltage is 12 volts. The required average output voltage is VA is 5 volts. So the output voltage at the load is 5 volts. At a resistance load R equals 500 ohms. So the load resistance is 500 ohms. And the peak to peak output ripple voltage is 20 millivolts. So the delta VC or delta VC is 20 millivolts. The switching frequency of the switch is 25 kilohertz. If the peak to peak ripple current of the inductor is limited to 0.8 amperes. Determine what is the duty cycle K, what is the filter inductance L, what is the filter capacitor C, and what is the critical values for L and C. At the beginning, we say that the givens are Vs is 12 volts, Va is 5 volts, R is 500 ohms, delta Vc is 20 millivolts, delta I is 0.8 amperes, and the frequency is 25 kilohertz. To determine the duty cycle K, we say that the average voltage at the output VA equals K multiplied by Vs. And already we have Vs and we have Va. This means that K can be obtained as Va over Vs, which is 5 over 12, which is 0.4167 or 41.67%. This is the first requirement. What is the duty cycle? What is the value of L? To determine the value of L from the giving, delta I, the peak to peak ripple of the current of the inductor current is 0.8. And we know that delta I is given by VA multiplied by Vs minus Va over F multiplied by L multiplied by Vs. Or we can say that it is K multiplied by Vs1 minus K over F multiplied by. But actually, the giving here are Vs and Va. And already we have obtained the value of K. So instead of using K, and maybe we are wrong, we are going to use the already given values. So Va is 5, Vs 12 minus 5 over delta I. This is the required is value of L, so we can take L here and delta I here. So delta I is 0.8 multiplied by the frequency 25 kilohertz. 25 kilo is 1000, so 25,000 multiplied by Vs12. By calculating this, we can obtain the value of the inductance which correspond to this ripple current delta I. So the value of the inductance in this case is 145.83 microfarad. The value of the capacitance it can be obtained from delta Vc. Delta Vc, as we have proved in the previous two videos, delta Vc equals Va multiplied by Vs minus Va over 8 LCF squared Vs. Now, we have already delta Vc, but it is required to determine the value of C. So we can see that C equals this over this over delta VC. And as another form, delta VC can be simply delta I over 8FC, and where delta I is VA VS minus A over FL VS VA VS minus A over L F VS, so the remaining are 8FC. Okay, so we can say that C equal delta I over 8F delta VC. C equal delta I is 0.8 over 8F 8 multiplied by 25 thousandths multiplied by delta VC. Delta VC is 20 millivolt, 20 multiplied by 10 to the power minus 3. So this is the value of C. We have taken C here and delta VC is here. So the value of C, or calculate C, is in this case is 200 microfarad. These are the value of L and C for such delta I and delta VC. The question now, what is the critical value of L and what is the critical value of C? The critical value of L, what is the maximum value of L, and C, what is the minimum value of C. So the critical value of L critical equals 1 minus K multiplied by R over 2F, which we have already proved. 1 minus K, 1 minus the duty cycle, 0.4167. R is 500 ohms. 2 multiplied by F, 2 multiplied by 25 multiplied by 10 to the power 3. So the critical value of L is 5.83 millihenry. And actually we are using much smaller than this value. We are using 0.14 millihenry. So this is the critical value of the inductor. On the other hand, the critical value of the capacitor for the present case with this value of L, the critical value of the capacitor is 1 minus K over 16 L multiplied by F squared. It should be noted here that this is the value of the L which we have used in our problem, not the critical value of L. So 1 minus K over 16 L F squared. So it would be 1 minus 0.4167 over 16. The value of L, which we have already obtained, is 145.83 microfarad. Micro, it means that is multiplied by 10 to the power minus 6. 145.83 multiplied by 10 to the power minus 6. This is L multiplied by F squared. From this, we can obtain that the minimum value or the critical value of the capacitor is 0.4 microfarad. And already we are using 200 microfarad, which is much greater than the critical value of the capacitor. This was an example about buck regulator. In the following video, we are going to discuss another type of regulator, is boost regulator, which is used as a step-up regulator. Alright.